Good. So for every vector v, we have agreed that we're going to be having how many? The x component, the y component, and the what? The z component. Are we together? Good. Now, the fact that we're going to be having these three components over here, we used to represent the y, we used to associate it with a vector notation I. Right? For the z, for the y, we used to put y associated with j, and then for the k, for the z component, we used to associate it with what? With k. This enables us to be able to add vectors together and to multiply vectors together. For instance, if a vector, if I have a vector A, I can represent this vector as 2i minus 3j plus k. This can be a vector. I can also have another vector represented this way. This can be I minus j plus 3k. What does this mean? It simply means that I have a vector that is located 2 along the x-axis, right? 3 along the y-axis, and then 1 along the z-axis. Right? Remember I told you that this vector, when we represent this vector, this is x and y. This is our origin, right? Now we are talking about having another direction, z, right? This is the z direction. Do you understand? So if this is supposed to be like 2 and this is, let's say this is 3, right? Fantastic. Which means this is located at 2, 3. But I'm considering this other direction, which is the z direction. So if I have a vector located somewhere here, right? Somewhere here. So I'm going to consider both the y direction, the x direction, and also the z direction. Are we together? Fantastic. So I can have a vector if I trace the z direction and it's somewhere here. Or I trace the z direction and it's somewhere here. Right? That means the point is somewhere here. So here I'm going to be having the I, the j, and the k component. Where the I represent the what? The x direction, the j represent the what? The y direction, and then the k represent the what? The z direction. Any question? No. Now, it's very simple for us to see that we can add these two vectors together. For vector addition, right? For vector addition, you add them component by component. What do I say? Component by component. For instance, if I have a vector A, I have a vector B, and I have this as A1I plus what? B1J plus, let me just use A or 2. So I can say A2 and then A3, right? A3K. And if my vector B is represented as B1I plus what? B2, B2J, now plus what? B3 and then K. I can have vector A plus vector B as what? A1 plus what? B1. Are we together? And this is the what? The I component. Are we together? Fantastic. So I'm going to be having A2 plus what? B2. And this is going to be the what? J component plus, lastly, A3 plus what? B3. And this is going to be what? The K component. So for instance, this example over here, if I'm going to add these two vectors together, what am I going to get? I'm going to get what? I'm going to get what? 2i minus what? plus this I over here. Are we together? This is for the what? This is for the what? I component. Plus into minus 3 plus what? Minus 1. So I have plus minus 1. This is for the what? J component. Now, lastly, plus for the K component, we have what? 1. 1 plus what? 3. Now, this is for the what? The K component. Can you see how simple this is? Now, if I add these two, I'm going to get what? 3I. Is that not so? What about this? Minus 3 plus minus 1. Minus 3 plus minus 1. Minus what? Minus 4. So we have minus 4 what? J. Is that not so? Then lastly, we have plus what? 1 plus 3, 4K. This becomes the summation of these two vectors. Are we together? Now, it is also applicable for negation, which means if I say vector A minus vector B, the difference is just going to be this sign. A1 minus B1. This should be for the I. Are we together? Yes? What is it? What's going on here?